In order to determine the x and y coordinates of the gymnast's center of gravity, we're going to need to zoom in on the picture of the gymnast, or at least the simplified picture of the gymnast, and determine the x and y coordinates of the four centers of gravity of the arm, torso, thigh, and leg. So we're going to look at that picture along with the chart. Let's start with the arm. We can see that the x coordinate of the arm's center of gravity would just be 0 because it lies on the y-axis. But then the y-coordinate of the arm's center of gravity would be the length of this vector right here. Now the table gives us the length of the vector that points towards the center of gravity of each body part. So in this case, it's just 0.236. So there are the coordinates for the arm's center of gravity. Let's move on to the torso. The torso will have an x-coordinate equal to the length of this vector. And for the torso, that is given as 0.337. And then the y-coordinate for the torso's center of gravity would just be 0 because it lies on the x-axis. We move on to the thigh, and the thigh's x-coordinate, or the thigh's center of gravity's x-coordinate, is a little bit challenging because we have to find this distance right here. We'll call it x. But then we're going to have to add that little distance to the entire length of the torso. That would give us the full x-coordinate for the thigh's center of gravity. To find x, though, we're going to have to make a little right triangle. So why don't we actually complete that right triangle, call that y, and make a little hypotenuse there. Now the length of that hypotenuse is the length of the vector for the center of gravity of the thigh, and that is given as 0.149. We know that the angle inside right there is 60 degrees. It's marked in the diagram. So that means that this little x distance, because it's adjacent to the 60-degree angle, is going to be the 0.149 cosine of 60. And then the y is going to be 0.149 sine of 60 because it's opposite of that 60-degree angle. So again, for the x-coordinate for the thigh, you're going to have to add the length of the torso, which is that number right there, plus this 0.149 cosine 60. So let's go ahead and do that. So 0.597 plus 0.149 cosine of 60, that's 0.6715. 0.6715, that's the x-coordinate for the thigh. And then the y-coordinate is just this little height right here. That's going to be easy because it's just 0.149 sine of 60. So that's 0.129. Finally, we can move on to the leg. Let's clean this up a little bit first. Now, the leg is going to have an x-coordinate that's a little tricky to find. We're going to have to add the length of the torso plus the length of this distance right here plus the length of that vector right here. Now, we know the length of the torso. That's 0.597. We know the distance to the center of gravity along the leg. That's given in the table as 0.227. But to find this, which we'll call x, we're going to have to do another little round of trigonometry. So let's make ourselves a right triangle like this. We'll call that y. Now, the entire length of the thigh is 0.376. That serves as the hypotenuse of this blue right triangle. This little x-coordinate then is going to be 0.376 cosine of 60. And then this y is going to be 0.376 times the sine of 60. Now again, to get the x-coordinate, you're going to add this distance plus this distance right here. Those represent those three blue segments right there. So 0.597 plus 0.376 cosine of 60 plus 0.227 gives us 1.012. 1.012. The y-coordinate is easier for the leg. It's just this right here. It's going to be the 0.376 times the sine of 60. That is 0.326. So finally, we have the x and y coordinates of all of the centers of gravity for the four body parts. Now we can start to get the coordinates of the center of gravity overall. And to find the x-coordinate, we're going to apply the following equation right here. Now this looks a little intimidating, but it's relatively easy. So what it tells us to do is to multiply the mass of each body part times the x-coordinate of the body part's center of gravity, and then divide that by the total mass of all four body parts here. So we'll set up a very long fraction here. We'll start out with the arm, and the arm has a mass of 6.81 and an x-coordinate of 0. So you'll take those two numbers and you'll just multiply them together. 6.81 kilograms times 0 meters, like so. And then you'll move on to the torso. The torso has a mass, we'll just leave that, has a mass of 33.6 and an x-coordinate, goodness gracious, of 0.337. So the mass was 33.6 and it's 0.337. 33.6 kilograms times 0.337 meters. We can move on next to the thigh, whose mass is 14.1 kilograms times the x-coordinate is 0.6715. Let's clean this up a little. And then finally, the legs, which have a mass of 7.58 and an x-coordinate of 1.012. So 7.58 times 1.012. And then below that, you're just going to divide by the total mass. So it'll be 6.81 kilograms plus 33.6 plus 14.1 plus 7.58. Those are all in kilograms. And then when you punch this into your calculator, you should end up with 0.458. And that will come out in meters. So that's the correct answer for the x-coordinate of the center of mass. You're going to do the exact same setup for the y-coordinate of the center of gravity or the center of mass, but you're just going to use the y-coordinate. So we'll set it up in the same way, but we'll be using these numbers in blue as our y-coordinates. So there is the setup. Again, we use the y-coordinates here, 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 and there instead of the x. And when you punch this in, you would get 0.0949 approximately meters. So that would be the correct answer for the y-coordinate of the center of gravity.